Okay, what we're going to do next is copy in our grid search CV function from last time. Um, Here it is, and we're just going to add the score to it. So, if you go back to your previous notebook, so if you're in a cell, you can just hit Command A and it'll copy everything inside of the cell. So I'm going to Command C to copy that. Go back to my new notebook. All right, say what I'm doing here, right? Grid search function, and put it in here. And then let's check what we've got here. I guess I didn't need that. We've got the parameters. Now note that the import here, so this could be copied on itself by itself. And then, everything looks fine. We're just, I guess today's not the day that I'll talk about the difference between training and test set separate from the grid search set. We didn't actually split it. It's okay to just use X and Y for now. Okay. And let's also return the best score with this. So grid dot, why grid dot? Because that's the model grid fit, and then best score, right? So let's get both. Okay, so after you've added that and copied in your grid search function, again, I just made this last addition. This returns a tuple, so it returns both. And let's just quickly test to make sure that it works. So I want to set my parameters first. And I can just even copy it. It's a little lazy to tie up. The params equals dictionary, quote, max depth. And then I put in the range of values as a list. In Schoology, you can do the none and 2, 3, 4, 6, 8, 10. And then now I can do grid. Uh-oh. I say uh-oh because it's grid CV, grid search. What did I call it? Grid search. Yeah, to try to make it indicative of what it's doing, it's searching the grid with these parameters. And I press Shift Enter. You can see it returns the best two things, the max depth of 3 and the best score with it. Great. Okay, time to move on. So what are the other hyperparameters? Well, there are different ways. As I mentioned, you can find them. One, if you just search decision tree classifier, which is what you're using, and you can look at the sklearn documentation, and it actually gives you, so it's all these terms, like here's max depth, all these terms in here are different hyperparameters. And so let's start with, so some are like more intuitive than others, I think. Let's go with an intuitive one. It's called min samples leaf. Okay, what does it say? And by the way, and why am I showing it to you like this? The reason why is because I'm trying to give you the, not just like, hey, here's how you do it, but to show you how to learn for yourself. Because if you're fine tuning another model, this is how you could find all the hyperparameters, little descriptions, and you can certainly search them for more information. So let's just read it. The minimum number of samples. Now, you might be wondering, like, what's a sample? A sample is like a row, okay? Required to be at a leaf node. Now, the leaf is the end of the tree, okay? So, like, if you split the data like 50 times at the very end, this is how you can get the perfect predictions. You may just have like one row left, right? Well, if that one row, someone has a heart disease or not, that's easy to like adjust because, or you're going to get the predictions right because it's like, well, in this case, clearly the person has a heart disease. So and it's like an if 50 things, if this and that and that, then they have a heart disease. Okay, well, minimum samples means that you can actually stop at a certain threshold. You can say, you know what? We're not going to keep going if once we hit 4 rows left, okay? So if there are only 4 rows left, we're going to stop. And we're not going to do any more splits. So what this does is it allows it to generalize better, right? It prevents overfitting when you increase min samples. So let's just try it by itself and see what happens. Now, I do want to mention that this data set is small. It's only like 300 rows. So I'm copying the, I'm just going to copy the whole thing. Why? Because it has the right format. And so instead of max depth, I'm going to put in the new one, min samples leaf. Okay. And none is not an option for this, right? The minimum is 1. And then so the idea would be that, a greater minimum leads to better generalizations. Okay. I think you could do something like that, like similar to max depth, for like a split, right? And so again, just to be clear, I think you want to know what this means. 1 means, hey, you know what? We're not going to put any minimum. If you want to split the tree like 100 times, you get, or 300 times, you can get all perfect all ones. Fine. 2 says, you know what? You get two samples in a minimum of 2 samples in a leaf, so you have to stop there, etc. Okay. So 10 means, hey, guess what? You got 10 samples in your leaf. We're not going to split anymore. We're stopping. So like max depth, increasing min samples leaf generalizes better. Okay, it cuts down on the variance. All right, let's see what we get. Interesting. 10 was the best. Okay, so I want to do it again, right? Because 10 is a little high. And let's try it like starting maybe at, well, I'm going to copy it again. We'll keep the results there. And now let's go like start with 9, 10, 11, 12, 14, 16, 18, 20. You go too high, you're not going to get that many splits. Okay, let's try that. So it runs it again. Wow, look at that. We got the best score yet with a minimum of 18. You see, this is cool, right? Because so what this is showing us, what this is revealing to us is that, hey, if we stop building the model, right? Not just determining like the number of branches, but we stop based on the number of rows in each leaf, like in each level that you reach, then you're going to get like the best result if you stop it at 18. That's what this is telling us. Now, let me take it one step further. We're doing this in isolation. We're doing max depth in isolation. So what if we do them together? What are we going to get? And the first thing I want to do is I just want to show you, let's see. Okay, max depth of 3 and min samples leaf of 18 gave us the best results. So you may think, well, combining those would give us a better result. Well, let's find out. Okay. I put this in here. And now see, for the dictionary, you certainly can have multiple entries. So you put a comma, it's just a dictionary. You put in the max depth. And, I can just copy in my same little options, which were here, with the none. There it is. Oh, I'm sorry. What I'm doing here is I jumped ahead. Like, okay, so this would be searching them all. But before we search them all together, I want to talk about that in a minute, okay? Let's just try the 2 best ones. So if the only options we give it are 18 and 3, then the fact of the matter is it's not really a grid search, but what's cool is you can do it in the grid search function, and it's just the only combination is 18 and 3. So it's going to give you the score for 18 and 3, right? So let's see what that gives us. 81.4%. Interesting. So it in effect matched the min samples leaf. Wow. I wasn't really expecting that. Let's just try the groups together. Now, when I do them together, okay, well, let's just see. I mean, I'm using the best ones. I maybe want to include a lower one here too. All right. Maybe even another lower one. Because, right, why am I doing that? The reason is that before, when you did max depth by itself, min samples leaf was 1. And when we did max depth by itself, by the way, min samples leaf by itself, max depth was none. So frankly, you could go a little higher and lower in both. However, okay, this is only 300 rows. what Grid Search CV does is it searches every combination. So let's count how many that is here. So basically for 5, if we take min samples of 5, it's going to do 1, 2, 3, 4, 5, 6, 7. It's going to search all 7 different max depths. Okay. So how many times are we going to search 7? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we're doing here, no, I haven't run the code yet for good reason. We're going to be taking 7 times 7, 10 times. That is, how many models are we looking at? 282,000 models, but these are 5-fold, so over 1 million models that we're building. That's too much, especially if you have big data. Okay, you've got to understand how grid search works. So it's better to do like a 4 and 4 type of thing. Look, we see what we got here. The point is, can we beat it, right? So let's use what we have to try to like finesse it. Like use what we have, use what we know to try to give us a smaller range. So why don't I just try 2, 3, 4, 6? Okay, you know what? This is a small, we could probably get away with 5. So maybe I'll go 2, 3, 4, 6, 8. And because 18 was the best, I'll use that as a center place and try 12, 14, 16, 18, 20. So now I've got 5 by 5. Wait, what am I thinking? Is that, I'm not counting this right, am I? I was thinking that was 25, but it's 5. See, each of these is going to build 5, so it's 5 to the 5th. So that's still pretty high. And you may wonder, why does he keep doing this? 3,125 models, that should be okay. Sometimes you can just try it and look how fast it is. Wow. And look at that. See, we got a better score with a max depth of 4 and a min samples leaf of 16. And this is to be expected. The reason why is because the point is not actually to tune them in isolation. The point is to tune them together. And you can see that by searching just a small combination together, we got like a good score. And hopefully you can also see from the little mathematical analysis that I'm giving you in terms of counting the number of possible models that you do have to watch it. Because if you do some crazy grid search, like imagine you just do 10 options for all of them, you could end up with like trillions of models, and it could just take like, it just won't finish because it'll be searching them like forever. It will feel like forever. It'll be finite, but you might be old before it finishes running. Okay, so you got to use your mathematical knowledge. And again, all I'm doing is I'm taking the 1 to the other power. This is like how you figure out combinations. Okay, so this is what min samples leaf is, and this is how we use really multiple, and you could say hyperparameters to tune together in Grid Search CV.